Whenever I create videos talking about MAC addresses and how switches learn where MAC addresses are in a network, I'll often see the comment, "This requires ARP." And I'm going to hopefully dispel that myth in this video. ARP is not required for a switch to learn MAC addresses and learn where devices are in the topology. ARP is often the protocol that updates the MAC address of switches, but it doesn't have to be ARP. In this topology, I have got a Windows 95 computer, Windows 98 VMs running on a Windows 11 laptop, Windows 11 here, and a Windows 98 laptop over there. If you're wondering why I'm running such old versions of Windows, it's to make the point that ARP is not required, because neither this laptop nor those Windows 98 VMs or that Windows 98 laptop at the top there are running IP version 4. They are only running a protocol called NetBEUI. These Windows 11 laptops are not running IP version 4 either. They're only running IP version 6, but their MAC addresses can still be learnt by a switch. So on this Windows 95 laptop, if I go to Settings, Control Panel, and look at Network, what you'll notice is there's no IP version 4 here. The laptop is running a protocol called IPX SPX as well as NetBEUI. No IP version 4 at all on that Windows 95 laptop. If I have a look at these Windows 98 VMs and I do a simple command that a lot of us would run. So ipconfig in a command prompt, notice it says cannot read IP configuration. That's because, once again, I am not running IP version 4 at all on this virtual machine. I'm only running NetBEUI. But that doesn't stop communication between that virtual machine and this Windows 95 laptop. If I go to Network Neighborhood, I can see Toshiba Windows 95 1. I am connecting to the C drive on this computer. And I can prove that as an example by deleting this test file on this Windows 95 computer. In the C drive, there's a file here called test.txt. But what I'll do is delete that from that virtual machine up there. And what you'll see is the file has disappeared. What I'll do here is create a new text file called test2. And what we should see is that appears in Windows 95. But what I'll do here is just say, hello, Windows 95 from Windows 98, and close that and save the file. So there's the file now on Windows 95. If I double click on that, I can see the file on Windows 95. So there's communication between those two devices using this old protocol called NetBEUI. Now you may be thinking, David, why are you showing me this old nonsense? We don't use that today. But the point still stands that MAC addresses can be learnt by the switch. In the same way, this laptop is not running IP version 4. So this network interface card, Ethernet 9, if you look at the speed here, it says 10 megabits per second. And that's because this laptop is connected to this hub. The reason I'm using a hub is that I can capture traffic. So I can see all the traffic in the network. Not just traffic sent to this laptop, but traffic sent from any device to any other device. But if I look at the properties of this, what you'll notice is IP version 4 is not enabled. I've disabled that protocol stack. The only protocol that's enabled is IP version 6. In a command prompt, if I type ipconfig as an example, this interface only has an IP version 6 address. There is no IP version 4. The same is true with the Windows 11 laptop here. If I connect to that and open up a command prompt and type ipconfig, what you'll see is only IP version 6 is enabled on this interface. And notice this IP version 6 address, FE80, B92, etc. I should be able to ping that from this laptop. So on this laptop, I'll ping that IP address. Again, the IP address is FE80, B92, D7E8, A60B, B23F. Now, just before I press enter, I'm going to run Wireshark so that we can see the traffic on the network. I'm capturing traffic on interface 9, which is our network connected to the hub at 10 megabits per second. It's actually this gray cable right here. I'm using a hub in this example so that I can see all traffic transmitted. So straight away, I can see a Cisco switch sending spanning tree information. That's because the Cisco switch is connected to the hub. You can see a bunch of Cisco traffic, but what I'll do now is press enter for the ping. As you can see there, the ping succeeds. Now it's a hub, so traffic's not going to be perfect, but we got 2 pings there. And in Wireshark, what you'll notice is we see ICMP traffic. So ICMP version 6. So if I search for IPv6, we can see IPv6 traffic. Otherwise, we can see spanning tree and other protocols here. We can see NetBEUI as an example. So if I go back to my VM over there and try and connect to the Windows 95 computer, what you'll see is we're seeing a lot of SMB, LAN-MAN, NetBEUI traffic. That's because we've got NetBEUI between this virtual machine and this Windows 95 computer, but we've also got IPv6 between these 2 Windows 11 laptops. So as you can see, a bunch of NetBEUI traffic. But what you'll notice is if I filter for ICMP, we don't see ICMP. If we filter for IP, I don't see IP here. There's no IP traffic. There's only IPv6 traffic. No IP traffic at all in this network. If I search for ARP, there's no ARP traffic in this network. But that doesn't stop the switch learning about MAC addresses. So I've connected now to the console of the switch, 9200 series switch, so a very modern switch. If I type show MAC address table dynamic, what you'll see is we learn a lot of MAC addresses, all connected to gigabit 101 because the switch is only connected to the hub on that one port. But as an example, notice this MAC address here ends in 21EE. If I connect to my laptop here and type ipconfig/all, what you'll notice is it's that MAC address, which is Ethernet 9. This interface only has IP version 6 addresses. There are no IP version 4 addresses. So the switch has learned about this device's MAC address, even though we're not running ARP. There's no ARP in this network. Again, if we look at Wireshark and search for IP, no IP. Search for ARP, there's no ARP. Search for IPv6, however, bunch of traffic. There's our pings, ICMP version 6, echo request from this laptop, echo reply from this laptop. You can also see a bunch of multicast traffic. So IP version 6 multicast here. If I search for NetBEUI, bunch of NetBEUI traffic. Notice traffic from 3Com to VMware. There's a 3Com network adapter in this Windows 95 computer. Traffic is being sent between VMware and that device. We also see the Windows 98 laptop talking to VMware. That's all happening because when I go to network neighborhood, I can see various devices on the network, Windows 95, Windows 98, and we can see VMs here. So again, if I go to Windows 98, I can connect from this Windows 98 VM to that Windows 98 laptop at the top there. I see all of this traffic in Wireshark, but I don't see any IP version 4 traffic. Again, I'll clear the filter. I see spanning tree, I see DTP, dynamic trunk protocol, I see NetBEUI, I see IPv6. I do not see any IP version 4 traffic in this network, only IPv6, but the switch still learns MAC addresses. And just to make the point, what I'll do is I'll move this laptop now from the hub to the switch. So let's put it on port 3 of the switch. What we should see is the MAC address table updates to show us that a new MAC address is connected to port 3. You can see that interface has come up. On the laptop, I'll send some traffic into the network. IPv6 is not like IPv4 where it shouts the whole time. Notice the ping is succeeding. I can ping from this laptop to that laptop. And when I look at the MAC address table, notice the MAC address table is updated. Device with MAC address ending in 21EE is now connected to gigabit 103. ARP is not used at all in this environment. Again, there is no ARP. So if I search for ARP, nothing. No IPv4. I'm running once again IPv6 and NetBEUI. I'm not running IPv4, but the MAC address table of the switch is updated. So let's move all of these devices now to the switch. And what we'll notice is the MAC address table updates, showing us where the devices are. So at the moment, we still see MAC addresses on gigabit 101. But what I'll do now is let's do the ping between the two Windows computers again. Now, these ports are showing orange because spanning tree has to converge. I haven't got port FOST or spanning tree edge enabled on the switch, but notice there the ping did succeed. There we go. Pings are succeeding now. Previously, this device was shown to be on gigabit 103 over there, but those devices are all on gigabit 101. But if I run the command again, notice we can see devices have moved to different ports. Now we're seeing two devices on gigabit 107 because we have got VMs running within a laptop. So we have got multiple devices connected to this port. Let's send some traffic. So double click on network neighborhood, double click to get to Windows 95. So this VM here can connect to the Windows 95 computer, and these two devices can communicate using IPv6. On the MAC address table of the switch, we see the ports updated. This MAC address D27B, let's check what that is. It's probably this laptop. If I type ipconfig/all, we can actually see that this MAC address, 7C, ending in 8DAB, is the physical laptop. So that's the physical laptop, and that's probably the VM. So on the second VM, I'll send traffic into the network by connecting to the Windows 95 laptop. And I've done that now. So now we can see that 3 MAC addresses are shown on that port. Again, if I clear the MAC address table, show MAC address table dynamic, we don't see any MAC addresses at the moment because no traffic is being sent. But let's send some traffic into the network from these 2 VMs that are running NetBEUI as the protocol. So they can both connect to the Windows 95 computer. Show MAC address table. You can see that the MAC address table has been updated. So have these entries. So when traffic is sent from those VMs to the Windows computer, the MAC address table of the switch is updated. As you can see here, the same will happen when traffic is sent by IPv6. Again, you can see this MAC address, this laptop, is now seen on gigabit 103. So I'll just move that again to make the point. Interface gigabit 103 went down. You can see that went down. Gigabit 1011 has come up. So show MAC address table. We can see that that MAC address is now on gigabit 1011. And again, just to make the point, because people seem to confuse this, I am not running any IPv4 here. So again, if I search for IP, no IP. If I search for ARP, there's no ARP. All I'm running here is IPv6, bunch of IPv6 traffic here, and I'm running NetBIOS traffic. In other words, NetBEUI. You can see here's an example name query for Windows Win98 VM3. And in the NetBIOS information, we can see information. Toshiba Win98 1. So that Windows 98 computer there is asking for information about this Windows VM. We can see an announcement for VM4. We can see a name query here. So in other words, traffic is being sent between these Windows 98 and 95 VMs and physical computers using NetBEUI, no IPv4. Traffic sent between these 2 Windows 11 laptops is using IPv6. Again, there is no IPv4. So again, on this computer here, if I go to Network and Sharing Center, Network Adapters, Ethernet 9, now connected at 1 gigabits per second. Details, you can see MAC address, you can see IPv6 address, but not IPv4. Again, MAC address 8DAB, that is currently on port 107. So I'll just move that to 3. So 7 went down. We've lost a few MAC addresses because of the VMs. 3 came up. And when that device sends traffic into the network, we should see those MAC addresses magically appear, if you like, on gigabit 103. So what I'll do is send some traffic from this VM. Same on this VM, send some traffic into the network. So double click on the Windows 95 computer. Here I'll double click on the Windows 98 physical computer. Password to log into the Toshiba. So we can see some NetBIOS traffic. And then notice previously, nothing on gigabit 103. but now we have 3 MAC addresses on gigabit 103, the physical computer and the 2 VMs. Again, there is no IP version 4 traffic. There is no ARP. Switches do not need ARP to learn where devices are. They simply need traffic to be sent into the network. It could be IP version 4, could be ARP in IP version 4, but it doesn't have to be ARP. In IP version 6, there is no ARP. In IP version 6, we have other protocols. So we have DHCP version 6, ICMP version 6, MDNS. What you'll see is solicitation messages like neighbor solicitation, neighbor advertisement messages, and then the pings taking place in the network. So again, let's do that ping just to make the point. So I'll ping the other Windows 11 computer. Took it a while, but there you go. Pings are now succeeding. And if I scroll down in Wireshark, you can see the neighbor solicitation message there. If I search for ICMP, which will be IP version 4, no ICMP, ICMP version 6, you can see ICMP ping messages, so ping and reply messages here. Okay, so hopefully I've convinced you. A switch does not need ARP to update its MAC address table. The MAC address table of a switch is updated when traffic is received on the port. So when a device sends traffic and it arrives on one of the ports of the switch looks at the source MAC address in the frames. It doesn't have to be IP version 4 because that's a layer 3 protocol. MAC addresses work at layer 2. So we're using Ethernet here. So the switch is simply looking at the Ethernet frames. It's looking at the source MAC addresses in the Ethernet frames and then updates its MAC address based on those source MAC addresses. So if it receives an Ethernet frame on this port, gigabit 103, as we see here, the MAC address table is updated based on the source MAC address. It's got nothing to do with ARP. ARP is used in IP version 4 to find out the MAC address of another device. So if I want to talk to you, I need to find out your MAC address. So when, as an example, I ping you in IP version 4, an ARP is sent into the network saying, what is your MAC address, so that I can set up the frame correctly or encapsulate the frame correctly with your MAC address. Not required for switches to learn where devices are in the topology. MAC address tables do not rely on ARP. ARP would be used by a switch if you are trying to telnet or SSH to the switch, as an example. Shouldn't be using telnet today. But if you want to manage the switch and you use SNMP or SSH and you connect directly to the switch, then you are going to need the MAC address of the management interface. So show IP interface brief on the switch. If you were connecting to VLAN 1, at the moment has no IP address, but if you configured an IP version 4 address on that VLAN and you SSH'd to that IP address, then ARP would be used by the switch. But otherwise, it's just using source and destination MAC addresses at layer 2, if it's a layer 2 switch, to move traffic through the switch. Not reliant on IP, not reliant on ARP. Okay, long video. Hopefully that makes sense. I'm David Bombal. Want to wish you all the very best.